Okay, so you've reached Siemens Digital Health Series. We're going to, so I just gave people a minute to log in from their Outlook notification. So hopefully we got everybody moving to the system here. So just wanted to give you a broad view. So today we're going to talk about digital health. Yesterday, or last week rather, the last session we had, we really talked about agile development. So how is it that Siemens tools, or in general, you would think about how to do agile development of software? Now, this week, what we're really going to dive into is the meat of the complexity. And when we talk about developing software in a regulated environment, we have a whole bunch of things that we need to be concerned about and work into our development process that are special, right? And so to do that, we're going to have some discussions about a variety of different technical topics. Now, this slide is just contacting me. So if you have any questions about what we're going to talk about today, feel free to give me a call, send me an email. The historical webinar location, I think, is important because this last session that we had on agile development, we're going to assume that you've already seen that as part of this discussion. So feel free to back up and take a look at that if you're interested. It's a brief overview, sort of a thin cut, and if you need more information on any of that, the topics that we talked about there, feel free to let me know and we'll get back to you. So when we talk about regulatory compliance, there's a whole bunch of different topics that we really need to touch on. And of course, we are doing this in the context of a global organization. Most medical device firms these days are global in nature. We're selling into all the markets around the world, not just into the United States. We have some discussion about standards traceability, complex application landscapes, and really regulatory compliance is the piece of it we're going to talk about today. So when we do software development, we really think of it in two pieces. We have software planning, which is this whole agile development. How is it that we're going to integrate with different tools? How is it that we're going to drive our Kanbans and our task management, that kind of thing? And then on the back end, we have software design. How do we author design? And in our final two sessions, what we're going to talk about is low code, how to develop a lot of these platform software systems, not embedded systems, but platform development systems in the context of low code, mobile development, development on the cloud, microservices, et cetera. So there's a whole bunch of topics that we're going to have in the next two sessions that really are related to the software authoring. But today we're going to talk about the second half of planning, which is really taking that agile development process and integrating it with all the regulatory aspects that we want to discuss. So when we talk about software, a lot of times people think of medical devices and software as two separate things. And really, medical devices overlaps into software. So when we talk about software as a medical device, really that's contained inside of this medical device world. And when we develop software, a lot of times people think in terms of tools like Jira or TFS, and we're going to develop our software in an agile way over there, but that doesn't really take into consideration the fact that we have this world of regulation that needs to be integrated with the software development effort. And of course, medical devices is one type of software, but a lot of times these platform systems have other types of regulation we need to be concerned about, things like financial regulations and other types of regulations, depending on the kind of software. And in addition to that, a lot of times what happens is that software is not regulated. And what we need is the ability to develop our software in a way that allows us to have one project have a setup that's different than another project, and then be able to interrelate those projects together with a set of methodology and a data model. So when we talk about software as a medical device, we really have four different categories of software, different types of risk, and the different types of risk fit into different categories, and those different categories have different requirements. And so even inside software as a medical device, in this narrow cut of regulation, we have a whole bunch of different requirements for how we're going to categorize that software, the risk of the software, and the requirements are going to be different from project to project. So as we evaluate a new piece of software that we're going to develop, we really need to have a different set of rules and a different set of projects to manage the differences between these different types of activities. So when we talk about regulation, there are typical areas of concern. And I'm just gonna, these are the areas I'm going to discuss today. So of course, the first one is agile development methodology. How do we integrate what we're doing from a regulation standpoint with the agile development methodology? So we're going to talk a little bit about that. We've talked about that in the last session a little bit, but we'll talk more. Next one is really external standards. So how is it when we say we're going to be compliant with an external standard, not only how do we integrate those standards into the process, but as we develop a methodology and a traceability for how we're going to be compliant with those standards, how is it then that we persist those requirements and traceability as we, not only as we create new projects and develop new understanding and new pieces of software, but also as the software that we already developed, it's in the field, how is it then that we update that project to comply with new versions of those standards or new versions of a normative standard to help us understand how we're going to apply those external standards? So external standards management is a very important part of how we reuse these requirements over time. The next is risk management and FDA compliance with the 14971 document. So if you're specifically medical device software, we have to be concerned with that. And finally, I have some discussion about model-based systems engineering. So we can drive our design in a couple different ways. One of them is to drive it through sort of a SysML 2.0 compliant system where we're breaking the design down into levels, and we're going to drive it with a functional understanding rather than just with requirements. So there's a variety of different ways to drive our design. So those are the four things we're going to talk about as we go through today. So in our last discussion, we talked really about SAFe and scaled agile framework and agile development work, but today we're going to talk about how that model integrates with a V model. And when I say a V model, really the reason I say that is because a lot of the regulatory bodies see the decomposition of a design as a V model. So we have a systems or a user need that develops to or is refined into systems requirements, which is refined into design and design specifications. They see the definition of the design in that framework. And so on some level, what we need to be able to do is integrate those two models together. And so I talked a little bit about this model in the last session. And essentially what we're going to do, last session, we really talked about everything under the line. So when we talk about agile planning, user stories, how those user stories are decomposed, how we drive our task management and unit testing as a result of our agile definition, all that happens really under this line. It's all the integration with the different tools, all the software sort of centric view. But now we're going to talk about really everything that's above the line. And above the line, we have this decomposition or this construction that regulatory people think of when they think of how we're going to present the data back to them. And in this case, the construction is really user needs to system requirements to design requirements and design specifications. And in that way, we're going to decompose the design and relate it to our logical functions and system functions that are defined in our systems architecture. So, of course, once we get that flat view of the requirements, what that allows us to do is associate our verification and validation testing to each one of those, and it gives us a flat list to go through to execute our testing against. And really what the regulatory bodies are looking for is, what is your definition of good? Where does that definition of good come from? Which drives the question of standards and norm traceability. So if we want to say we're going to comply with a standard, we're going to break that standard down. The standard is going to be related to the requirements, and then the requirements are going to be tested. And that way we can say, here's our definition of good. This is what we think. If a person said, for this particular piece of software, what is good? This is our definition hierarchically, and here are all the tests that we did against those tests or against those requirements and the evidence that those tests were passed. So this is really the construction that people need when they look at a design to say, you know, did the company do what was necessary to prove that this device is safe and efficacious? Okay, so there's a couple different ways to break down designs. The first one is to drive our user stories on the basis of our defining the requirements. So if we define a design requirement or a design specification, one of the ways to drive our user stories is just to have the user story be a decomposition of those requirements. And that's a a good way to do it, in that what it does is it frees the software people from this V model methodology, but still provides the traceability back up into the definition of the design. So we can say, look, we want you to go out and develop this piece of software. Here's the requirement that is driven from our decomposition. Now build a user story from that and do your software development in a separate activity, in a separate project even. The second way to really do that is with a functional breakdown. And we'll talk a little bit about this, but this is the model-based systems engineering view, where we're going to go through in levels and understand what it is we want this device to do. As an output of that, we get a set of functions, and those functions are related to our requirements. That's another sort of view of it. Different ways different people do it. And one of the really important things about this is that when we look at our construction, our data model, that not only we have a clear methodology for how to drive our design, but in addition to that, we're going to have different divisions doing different things. Very typical that you have a highly complicated device and you're going to want to drive it with a systems engineering model. But maybe you have a piece of software that's really much simpler and we don't really need all that systems decomposition or functional breakdown. Okay, well, in that case, maybe we'll just do it with requirements. So we want to be flexible in the way we handle it, and we want to have the ability to reconstruct or change our data models in a way that's appropriate for this particular design. Okay, so this is really the discussion. Last session is under the line. This session is really above the line. So I'm going to go through some topics. The first one is really related to standards management. How do we manage these external standards? So typically, when we develop a standard or a normative standard, which is a decomposition or a pre-processing of the external standards, we're going to have a document, and that document has a bunch of atomic elements in it. Now, when we go to reuse that document, we're going to run off in a branching situation. So we're either going to, we have two different terminologies. We call it reuse and branching. It's really a technical difference, but essentially what we're going to do is we're going to say we have an understanding of this set of requirements, and that set of requirements in its historical setting is going to be reused into a project. And we can do that over and over again, and not only can we branch the document, but we can merge that document back into the original file. And in this way, and I'll explain this in more detail here in a minute, but because of branching and merging, we're going to be allowed to do reuse. And not only can we reuse the artifacts that are there, but we're reusing a historical understanding of those artifacts. And the important thing about that is those linking relationships then can be persisted as we update that document over time. And so if we go from revision A to revision B, what that means is we can now say we're going to update that set of documents to the new revision, and it's going to be persisted throughout all the projects that we've developed in over the life of the product. And so I'm just going to go ahead and talk through how that's done. Essentially, what we have is a process typically when people do development. We define the product, we identify the applicable standards, we pre-process atomic requirements in the standards into our own understanding of what those requirements mean for this particular type of software. So we write the requirements. A lot of times these standards step on one another, and we want to write those requirements so we understand what we're doing specifically for this type of software. We integrate that with risk management. We write the test cases and protocol. We execute the testing. And then very importantly, we update the product to standard changes over time. And so there's a maintenance aspect of this that we have to consider as we go along. So what we're going to suggest is that we reuse those 5 middle blocks from a library. So as we develop a new piece of software, what we're going to do is we're going to ask a set of questions. What kind of software is this? Is it a medical device? Is it does it have financial implications, or is it not any of those things and it's a simpler project? So what we're going to do is when we answer those questions, we're going to drive reuse by the answers to the questions. So essentially what we're going to do is we're going to share documents down into projects that are specific to this type of work that we're doing. And that really is a 15-minute operation, and we can get tremendous reuse out of this and drive standardization of how we're going to apply our products over time. So I'm just going to talk through a construction of how you can possibly do this. Essentially, we start with the standards library, and these two examples, 62304 is software for medical devices, 62366 is usability of medical devices, very typical standards you'd have to be compliant with if you're doing software as a medical device. So essentially we have the standard, we break the standard down into its composite requirements. Now we have a normative standard library. And the purpose of this normative library is to share and link the standards requirements into the normative requirement. And we're going to process this A on the basis of a few different requirements in different standards. And this is what I mean by very typically standards step on one another. We might have a requirement in 62304. Well, I mean, just one example, 60601-6 is usability for electrical devices. 62366 is usability for medical devices. Those standards step on each other. They have similar requirements, but stated slightly differently. So what we want to be able to do in our normative library is say, what do we want to do with this requirement, and how are we going to apply it to this product type? So this gives us two levels. And then what we do is we share these documents, these collections of requirements, down into projects. And what we do, when we do that, we get a bunch of really interesting capabilities. The first is these external standards are driven at a cadence that we can't control. And so what we can do, because we have a separate library for the external standards, whenever they get updated, we can update these and re-release them without any impact to the rest of the company. What that allows us to do then at the normative library level is process those standards as we see fit with the idea that we're going to apply this document to all of the different projects of this product type. And so when we finish with the labeling or the user interface document for that product type, we're going to have an understanding of how these standards should be applied to our products. Now, when this gets updated and approved, it becomes available to the projects. And so you can imagine at the project level now, we're going to have a historical understanding of what was shared to this project. And if we look up from the project to the library level, we'll see any new release documents that can be pulled down into this project. And what that allows us to do at a cadence that makes sense to the projects, hey, we have two revisions that are more current than the revision that's been shared into this project. We can do a differential between those two revisions of the document and get a good understanding of how and whether and the effort that's going to be required to update to the new version of this normative standard. So what this allows us to do is provide traceability all the way back to the standard. And of course, at the project level, we're going to link test cases and test results to that. So now we have the evidence that this project is compliant with that requirement of the standard through traceability. And so this is a very powerful way to drive compliance with standards. And the persistence of these linking relationships across projects is what really makes this whole process possible, which is a very unusual kind of setup for a product. So I'll just roll through a few reports. This is an example where we can show the standard requirement, the normative standard linking, and the test case in the project that's actually showing compliance with that particular standard. So now compliance with the standard just becomes a matter of simple traceability. Second thing, this is a report at the normative library level where we're looking at all of the different standards, internal standards that have been published. Where have they been published to? Under what revision were they published from? And what projects were they shared into? And in a big company, this might be 250 projects, right? And if there's 250 projects, very unlikely that those would all be shared at the same revision level. So now we have the ability to look at our projects and say, you know, is everything up to current snuff, or do we need to consider improving or upgrading the project to move it into a more current revision? I'll add to that the next report, which is the project up. So now we're going to look, what are all the standards that have been shared into this project? Where did they come from? Under what revision were they shared? And not only that, is there a later approved version? And if there is, what we can do is we can select the two and update the document, and it'll turn on suspecting, and it's going to tell us everything that's changed in this document and allow us to re-execute the testing so that we can become compliant with the new version of the software. So all this to say, standards traceability and an ability to show your compliance with those standards is critical to actually getting products approved through a regulatory process. One of the standard questions is, how are you going to show compliance with these standards? And this is a way to completely automate that process and manage it over time with persistence of links across projects. Okay. So if we have more questions about that, we can talk about it at a later time. I'm going to go ahead and talk about risk management, and this is another level of complexity. Typically, when we do risk management in medical devices, we have this requirement through the 14971 document to do risk analysis on the product. And software as a medical device is no different than any other device that's out there. You're required to decompose your risk analysis in a way that allows you to understand the impact to the users and develop a control strategy. And so essentially the 14971 document talks about harms and hazardous situations that cause those harms. And the idea here is you decompose these in a way that provides you with a mitigation strategy. And so in this case, we're going to do a hierarchical breakdown based on that V model we were talking about a minute ago. And essentially what we have is user needs that are mitigating the occurrence of those hazardous situations. So what we're going to do then is take the user needs, and my typical example, I apologize, this isn't a software example, it's just easy to make it clear. So let's say our harm is infection. The hazardous situation is that the device has harmful bacteria and it introduces that harmful bacteria to the patient. User need would then be that the device be sterile. So in this case, then we do a use FMEA that helps us to process these user needs in a way that helps us understand how the customer would use the device. And so then we come up as a result of that, as a deliverable from that use FMEA, we're going to end up with a list of system requirements. So in this case, the user need is the device be sterile, and we'll have a system requirement then that the device be compliant with a standard. And for 11135 is an example of that, a sterilization standard. So in the case of software, very different kinds of system requirements, but just as an illustration. So then we reprocess the system requirements to get design requirements through the systems FMEA. The design FMEA then processes the design requirements into the design specifications. In this case, we would be talking, the design specifications would be software specifications, and they'd exist inside the source code typically. And so what we're trying to do is get a traceability up into the risk analysis that shows us why we need this decomposition of controls. And of course, at that specification level, that final level is a characteristic related to safety or a critical to quality characteristic that's going to closely control the hazardous situation and the harm. So if any of these, what this ends up being is a chain of events that can occur to lead to the hazardous situation. Okay. And in the case of software, what we're really talking about at the process FMEA level is really DevOps, right? How is it we're going to build the software and deploy it in the field? So this is how we develop a control plan. Now, the reason for doing this is it's required by regulation, right? So part of what we got here is a standard that's driving a particular deconstruction. That deconstruction is giving us a data model, and the data model has to be related back to the requirements. So these are actually our requirements that would have test cases associated with them and test results that would prove that we're implementing and that this control is effective. So another piece of the puzzle that's required from the standpoint of actually getting the software out in the field. And this is just an example that's specific to medical device. Now, just a few reports that kind of drive this out. This is our traceability report that decomposes the user need to the system requirement, to the design requirements, specifications, the test cases, and then of course we can put test results there too if we want. But we have this atomic traceability as we run through the process. Now, one of the things that when we, where the risk management really fills in the gap is when we say we have a system requirement that's decomposed into design requirement, why is it that we have a design requirement that is related to that system requirement? It fills in the why. And the why is really because we can have an issue happen that will cause this system requirement not to occur. And so as we go through these design requirements, the justification for the design requirement is really the FMEA. And so just to break that down then, we have risk records, harms, hazardous situations. These are all hot linked reporting. And then our deliverable is really this user need. Just outline that for you. In addition to that, if we go to the use FMEA, the use FMEA has user needs that come from the initial report, just as I showed in the decomposition. But now we have this use error that defines what it is, the perception, cognition errors, failure effects, the root cause of the failure, and then what system requirement are we going to use to control the occurrence of that user need, or the possibility that the user need won't be met is really what. So again, same thing for sys FMEA, same thing for design. And so you can start to see how this data deconstruction is very important to being able to provide us with the traceability to show in reporting instantly how we're going to be compliant with those regulatory requirements. So risk is a real strong justification for having a data model that allows us to do all these different deconstructions. So finally, I'm going to talk a little bit about systems modeling. Our tool systems modeling workbench, what it basically is a SysML 2.0 application that allows you to deconstruct your design into layers and then graphically represent them in each one of those layers. And so essentially we have an operational, a systems, a logical, and a physical architecture. And the deliverable from this analysis is really a set of functions. And so if you want to do a functional breakdown, this is the type of tool that's done. Now the functions then relate directly to the deconstruction of our controls, right? So each one of these controls is really a requirement that's going to have test cases and test results associated with it. And what I always, when I talk about this, the risk management is really a negative view of the design. So what do we need to have in the form of requirements that assure that the next level up will be satisfied? So if I have a user need, what system requirements are required to assure that that user need is met? This is really, systems modeling is really the positive view of this, where we're saying, okay, what does the device need to do? What does the software need to do? If we can define what the software needs to do, then we can track that into the requirements too and assure that we have a complete set of requirements. Because sometimes we, if we only take a negative view of the design, we're going to mitigate a lot of risk, but it may not do exactly what we want it to do in the first place. So this is what systems modeling is all about, and this traceability into the control strategy. So we have an operational level that talks about functions that are user tasks in the process. We have a systems level, and the systems level defines for us what the system requirements are going to need to be. We have a logical level, and the logical breaks down these functions. So each one of these green boxes is a function then that has to be represented in the deconstruction of the design. And finally, we get to the software specific. So now what we do in the case of software is we do a view of the logical architecture that is specific to what we need to accomplish in the software. And so what this also allows us to do is separate. And one of the things I think that people don't realize, even software as a medical device really isn't just software. We're always laying the software on some physical architecture someplace. And we're designing and specifying what that architecture needs to be and testing against that architecture. So even in the case of software as a medical device, we are landing it in an architecture someplace. So you're likely in a systems analysis perspective, you're likely to end up with some hardware in that as well. And of course, once we do that, when we have this output from the device or from the different functional breakdowns, those use functions then end up getting associated directly with the architecture. And this allows us then to associate the risk management with the positive systems view and drive all this then in a flat understanding of all the user needs and the requirements. Now we have a flat understanding of what all the checks need to be. We associate test cases with those, we execute the test cases and get our test evidence. So kind of to circle this all around now, essentially what we're going to do is we're going to do this deconstruction of the user needs, the test cases, the system functions, and the standards and norms traceability in a way that relates to the software tool chain that we're developing under the sheet, so to speak. So we're trying to have free the software people to really execute on their software design in a way that's familiar to them, considering all of the integrations that they have to have, all the agile development methodologies and the reporting structures, while at the same time providing us that traceability and the rich reporting functionality on top of it to give regulatory bodies the type of output that they require to be able to say, yes, it's good, no, it's not good. So hopefully this is a pretty good preview. Just tried to walk you through it. We're pretty much out of time. So if you have any questions on any of this, I'd be happy to talk to you about it. This is a very complicated or complex topic. And of course, I've only talked about a few of the levels of complexity that you're going to have to deal with as you're doing the development of these different software types. But happy to have a further conversation if you want. And so if anyone is interested in the last two sessions, we're going to be talking about digital health and low code, and would love to have anyone else who's interested in the conversation come alongside. So thanks so much for your time today, and look forward to the next session.